Submersible pumps. Submersible pumps are specialized devices that operate while submerged in fluid, typically water or other liquids. These pumps are widely used in various applications, including drainage, sewage pumping, and deep well extraction. This document provides an overview of submersible pumps, their working principles, types, applications, advantages, and considerations for maintenance and selection. Working principle. Submersible pumps work by converting rotational energy into hydraulic energy. The pump is sealed in a waterproof casing, allowing it to be submerged in the intended fluid. When the motor inside the pump is activated, it drives an impeller that creates a pressure differential, drawing fluid into the pump and forcing it out through a discharge pipe. This design allows for efficient fluid movement and minimizes the risk of cavitation. Types of submersible pumps. Sewage pumps, designed to handle wastewater and sewage. These pumps can manage solids and debris, making them ideal for municipal and residential applications. Well pumps, used for extracting water from deep wells. These pumps are often multi-stage to provide higher pressure for lifting water to the surface. Drainage pumps. These pumps are used for removing excess water from flooded areas, basements, or construction sites. Fountain pumps. Smaller submersible pumps are used in decorative fountains and aquariums to circulate water. Applications. Submersible pumps are utilized in a variety of settings, including agriculture, irrigation systems and drainage of fields. Construction, dewatering excavations and managing groundwater. Municipal, wastewater treatment and sewage systems. Industrial, chemical processing and fluid transfer. Advantages. Efficiency. Submersible pumps are generally more efficient than surface pumps due to their ability to push water to the surface rather than pull it. Space saving. Their compact design allows for installation in tight spaces. Reduced noise. Being submerged in fluid helps to dampen noise levels during operation. Versatility. Suitable for a wide range of applications and environments. Maintenance considerations. To ensure optimal performance and longevity of submersible pumps, regular maintenance is essential. Key maintenance tasks include inspection, regularly check for wear and tear, leaks, and electrical connections. Cleaning, remove debris and sediment that may clog the pump or impede performance. Lubrication, ensure that bearings and seals are properly lubricated to prevent friction and overheating. Testing, periodically test the pump's performance to identify any issues early. Selection criteria. When selecting a submersible pump, consider the following factors. Fluid type, ensure the pump material is compatible with the fluid being pumped. Flow rate, determine the required flow rate for your application. Head pressure, assess the vertical distance the pump needs to lift the fluid. Power supply, ensure the pump is compatible with available power sources. Bottom line. In conclusion, submersible pumps are essential tools in various industries, providing efficient and reliable fluid movement. Understanding their working principles, types, applications, and maintenance needs is crucial for effective utilization.